Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying Quadratic Lecture 1. Quadratic as a chapter or a topic is very important in terms of PGDBA and we usually get 2 to 3 questions every single year from this particular topic. So let's start with this chapter. So I won't be going, into the very basics which we studied in 9th and 10th class. I won't be doing that because everyone knows that stuff. So I'll be telling you all those things which are relevant to PGDBA and are more conceptual. So if we want to define quadratic, then the first thing is we can write quadratic in this particular format: ax square plus bx plus c equals to 0. And also the basic definition says quadratic equation has two roots. It can be equal root, two equal roots, two distinct roots, or two complex or imaginary roots, but it has only exactly two roots, right? But in case a quadratic equation has more than two roots, it becomes an identity. But how do we define, how can we expect that a quadratic equation is having more than two roots? So let's see. What if this coefficient, and this c value becomes 0? So this would become 0 times x square plus 0 times b, sorry, not b, 0 times x plus 0. Now you can plug in any value of x over here that would eventually become 0 only. So basically this particular equation has more than two roots. So this is called an identity. So whenever the coefficients are 0 and all the constants, basically all the constant numbers and coefficients in a quadratic equation are 0, in that case, the quadratic equation becomes an identity. Let's try to look at it with the help of an example. What kind of questions can be framed in this particular concept? Find the value of a for which the following equation has more than two roots. So a square minus 5a plus 6 times x square minus a square minus 3a plus 2 times x plus 2a minus a square equals to 0. Now, if it has more than two roots, then basically this is nothing but an identity. And if it's an identity, in that case, this coefficient, and this constant number, all three should be 0 simultaneously, right? So for that, this let's try to make it 0 first. So for that, we'll be getting a minus 3 multiplied by a minus 2 as the factors over here. This would be a minus 2, a minus 1, and this would become a times 2 minus a. So basically minus a times a minus 2. So we can clearly see that a minus 2, a minus 2, a minus 2 is a common factor. Basically 2 is a common number in all these coefficients and constant numbers to make it 0, right? So basically a equals to 2 is the answer. If I plug in 3 over here, then but only this coefficient will become 0. So that won't make it an identity, right? So to make it an identity, I have to take one a value that is being satisfied by all three coefficients and constant numbers. Okay. So these are the kind of questions you can get for this particular concept. Now let us talk about the basics of quadratic equation. So again, the standard quadratic equation is written as ax square plus bx plus c equals to 0. Now, if we talk about discriminant, then discriminant is nothing but b square minus 4ac. I won't go into the derivation because that's not relevant over here. And discriminant is basically b square minus 4ac. Now, if we talk about the formula for roots, that is just the division part which we have studied in 9th and 10th class. So x equals to minus b plus minus under root d divided by 2a. D is discriminant over here. So this is the formula for roots. So we get two roots for quadratic equation with a plus sign and a minus sign over here. Okay. The third point is important: relation between coefficients and roots. So if we get this, let's say we have alpha and beta as the roots. So alpha plus beta would be minus b by a, and alpha beta would be c by a. So c is this coefficient, b is this coefficient, a is this coefficient, and c by a is basically the product of roots, and b by a minus b by a is the sum of roots. Now, how did we get that? Let's see that. So let's say we have this equation ax square plus bx plus c equals to 0. Now I'll divide this entire equation by a. So I'll be getting x square plus b by a times x plus c by a equals to 0. Now also we know that the roots of this particular equation is alpha and beta. So if the roots are alpha and beta, then x minus alpha, x minus beta should also represent this equation, right? So if I open this one up, that would give me x times minus alpha plus beta x square, sorry, x square minus alpha plus beta times x plus alpha beta equals to 0. Now I can make the comparison. Alpha plus beta becomes minus b by a, and alpha beta becomes c by a. So that is a very standard thing which you already have been knowing, but this is the proof. Now let's look at this example. Find k in the equation 5x square minus kx plus 1 equals to 0 such that difference between the roots of the equation is unity. Now this is the keyword, difference between the roots of the equation is unity. We don't really know if alpha minus beta equals to 1 or beta minus alpha equals to 1. We don't really know, right? So basically, mod of alpha minus beta equals to 1, this we know for sure, or alpha minus beta equals to plus minus 1. So this is how we have to interpret this one. Now we have to find out we have to utilize this equation. Now we know that alpha minus beta whole square equals to alpha plus beta whole square minus 4 alpha beta. If you just open it up, then you will get the same thing. So alpha minus beta whole square equals to alpha plus beta whole square minus 4 alpha beta. So over here, we are going to use alpha minus beta equals to plus minus 1. And since this is a square, it's not going to matter which sign we are using. So 1 equals to alpha plus beta. That would be minus of minus k by 5, right? Because we have minus of b by a. So that becomes k by 5 square minus 4 times alpha beta. That would be 1 by 5 into 1 by 5. Now this 25 goes over here. That becomes 25 equals to k square minus 5 takes the LCM. If I take the LCM, then it becomes 20. So k square equals to 45. So k becomes plus minus under root 45. Okay. Now let us talk about formation of quadratic equation. So as we have seen that, let's say we have this equation x square plus bx plus c equals to 0. And this has alpha and beta as the roots. So what we can do, if we know the roots of this of a quadratic equation, then how to form that equation back. So that would be x minus alpha x minus beta equals to 0. That is the common sense, right? But in this case, you can see that we don't have a coefficient of a over here, but we have a coefficient of a in the actual equation. So basically, what we'll be doing, we'll be multiplying a over here. So a times x minus alpha x minus beta equals to 0. Now, coefficient of x square has a very significant importance in terms of quadratic equations, because if a is greater than 0, that means parabola is facing upwards. If a is less than 0, that means parabola is facing downwards. So you have to remember this, and we have to be very careful with these things. Okay. Now let's look at one more question. If alpha is not equals to beta, but alpha square equals to 5 alpha minus 3, beta square equals to 5 beta minus 3, then equation whose roots are alpha by beta and beta by alpha is a very standard question. So let's see how it goes. Now we know that alpha square minus 5 alpha plus 3 equals to 0, and also beta square minus 5 beta plus 3 equals to 0. Now you can see that alpha and beta are satisfying a quadratic equation, x square minus 5x plus 3 equals to 0. So basically, alpha and beta are the roots of this particular quadratic equation. So alpha plus beta would be 5, basically minus b by a, alpha beta would be 3. And we have to find out the value of alpha by beta plus beta by alpha. That would give me alpha square plus beta square divided by alpha beta. That is nothing but alpha plus beta whole square minus 2 alpha beta divided by alpha beta. Now you can use these values and find out the values of summation of roots. You can find out the values of product of roots, and then you can find out the equation of the basically new equation. Now let us talk about nature of roots. So we have basically three major cases: discriminant greater than 0, discriminant less than 0, and discriminant equals to 0. So let's talk about the case 1. So we again have the standard equation ax square plus bx plus c equals to 0. Now we know that discriminant is b square minus 4ac, and that comes under the root. If we talk about roots, then that would be minus b plus minus under root d divided by 2a. Now, in case discriminant is greater than 0, then what we'll be having? We'll be having two different kind of roots, right? Because that is a real number and that is inside the root. So the first root will be with the plus sign, the second root will be with the negative sign, and we'll be having two distinct roots in case if it's greater than 0. Now, in case if it's less than 0, in that case, we'll have a complex number over here, but again, we'll be having two complex roots. In case discriminant is equals to 0, in that case this would become 0, right? And we won't be able to utilize this plus minus sign, so basically we'll be having just one root, basically two equal roots, not exactly one root, two equal roots. Okay, now let's look at this particular example. Let PQ belongs to this particular set. These number of equations of the form px square plus qx plus 1 equals to 0 having real roots is. So it's talking about having real roots, but it's not saying that having distinct real roots or having equal real roots. So we'll have to take the case of b greater than equals to 0. So basically p square, in this case q square minus 4p is greater than equals to 0. Okay, now we'll have to do the manual stuff. So if I take q equals to 1, then it's not possible to have any value of p for which this entire discriminant becomes greater than equals to 0. So q cannot be 1. Q cannot be 1. Now q can be 2. If q equals to 2, then p can also p can become 1. In that case, p equals to 1, because that would make this entire equation 0. Now, if q equals to 3, then in that case, p can take value as 1 and 2. We cannot take 3 because that would become 12 and this would become 9, and that would become negative, overall negative. So p equals to 1 and 2. Now if I take q equals to 4, in that case p can be 1, 2, 3 and 4 as well, right? Because that would become 16. In case of q is 4, this would become 16, and p is 4. In that case, that 4p also would become 16. So this overall becomes 0. So p equals to 1, 2, 3 and 4. So basically 1 from here, 2 from here and 4 from here. So overall 7 equations can be formed having real roots. Now let's discuss nature of roots in more detail. So the case 1 is ABC are rational numbers, D is greater than 0 and D is not a perfect square. So in that case, the outcome is roots are conjugate pair of surds. So what do we mean by that? So we again have the roots like x equals to minus b plus minus under root d by 2a. Now let's say d is greater than 0, but it's not a perfect square. So basically it would likely, it would stay in the root only, right? It would not come out of the root because it's not a perfect square. In that case, we'll be having a root with plus under root something and minus under root something. So basically it's occurring in pairs because it cannot come out of the root and get added onto minus b, right? So that is why it come in, these kind of roots come in pairs. So the condition is d is greater than 0. All these three are rational, and d is not a perfect square. In that case, we can have this kind of format. Now, what kind of questions can be asked over here? So let's say they'll be giving you root, a quadratic equation is there, and the root is one single root is root 2 plus 1 by 2, let's say. So you have to find out the other root, or you have to do something with the other root. So you have to assume that since these kind of roots occur in pairs only in case of quadratic equation, so the other root would obviously be root 2 minus root 2 plus 1 divided by 2, because we have a plus minus over here and this cannot come out of the root because t is not a perfect square, right? So these are the kind of questions that can be framed based on this particular property. Now, case 2 is ABC are rational, D is greater than 0, but D is a perfect square. In that case, roots are rational. That becomes very obvious. So basically, roots will be x equals to minus B plus minus under root D by 2A. Now, this can come out of the root and can get added with B and divide by A, right? Because all these three are rational. This is not irrational because D is a perfect square. So in that case, will not be having that kind of pairs, and we cannot really find out the value of other root with the help of one single root. So in case ABC are rational, D is greater than 0, D is a perfect square, then roots are rational. Now the case 3 is if ABC are real and D is less than 0, then roots are a complex conjugate. Similar kind of thing, x equals to minus B plus minus under root D by 2A. Now let's say this is let's say -5. So you can write it as not -5. Let's take a good number. Let's say -25. So that would become 5 iota. We can write this as 5 iota. So again, this is a complex number. This is not a real number. It cannot get added to minus b individually and divide by 2. We cannot do that, right? So that's why it stay in this particular format. And again, they also occur in conjugate pairs. So if one root is 5i, then other one root is having 5i, the other root would be having -5i in the pair. So that is in this kind of pairing format, these roots occur. Okay. Now let's look at this example. If alpha and beta are two distinct roots of x square, two distinct roots of x square plus bx plus q equals to 0, and alpha 4, beta 4 are the roots of x square minus rx plus s, then the equation x square minus 4qx plus 2q square minus r equals to 0 has always and these options. Now let's try to solve this one. So over here, from this particular equation, I can see that alpha plus beta equals to minus p and alpha beta equals to q. And we don't really know except that these two roots are distinct. We don't really know if they are positive or negative. We just know they are distinct. So this is the information which we can derive from this first equation. And from the second one, alpha raised power 4 plus beta raised power 4 equals to r, and alpha 4 beta 4 equals to s. So we definitely know that r is a positive number because both of them are different and distinct. So only one can be 0. So definitely r is a positive number, not even greater than equals to 0. It's greater than 0. And similarly, s can be either 0 because one of the root can be positive, can be 0, right? Although they are distinct, but one of the roots can be 0. So s is greater than equals to 0. So this one is greater than equals to 0. This one greater than 0. Okay. Now we have to find out the properties of this particular equation. So firstly, to identify if this has two real roots or not, we have to find out a discriminant. So discriminant for this particular equation would be 16q square minus 4 times 2q square minus r. So that would be 16q square minus 8q square plus 4r. That would eventually become 8q square plus 4r. Now this q square is a positive, or you can say that this is greater than equals to 0. It can be 0, it cannot be 0, but it's definitely not negative, non-negative number. And this particular number is, we have derived that this is greater than 0. It's not greater than equals to 0. So this is greater than 0. In that case, we can clearly mark this option A, two real roots. Now we have to comment on the negatives and positives of the roots, if the roots are positive or negative. So how do we do that? So for that, product of the roots is a very important thing to understand. So we have alpha plus beta over here, not alpha plus beta. Let's say this is a1 and a2. Roots are a1 and a2. So a1 plus a2 would be 4q, and a1 a2 would be 2q square minus r, right? So this would become, q is basically alpha beta. So this would become 2 times alpha square beta square minus r. R is nothing but alpha raised power 4 minus beta raised power 4. So this would become minus times alpha 4 plus beta 4 minus 2 alpha square beta square. And we know that this is nothing but alpha square minus beta square whole square with a minus sign. So this is definitely a negative number over here. And we know that alpha and beta are two distinct roots. So this cannot be 0. So either one is positive and one is negative. This is the true understanding with the help of this information. Okay. So this is the kind of question, this is the kind of maximum difficulty question you can get in PGDBA for these kind of concepts, very basic concepts. These are the 9th and 10th class concepts. So today's lecture for quadratic is still here only, and we'll meet tomorrow for the second lecture. Thanks for watching.